Hey, welcome back. You're watching Centerline Designs. My name's Cole if you're new to the channel. And this is our rocket stove water heater build. This thing is awesome. It's completely stainless steel. We have a 2.5 gallon water jacket sitting on top of a rocket stove with a bunch of tubes inside of it that you'll see that allow hopefully a good amount of heat transfer from that really hot rocket stove fire into water, into our redneck hot tub behind us. Now this is only a test. I don't think I'm going to be going hot tubbing in this video. What I want to do is take 100 gallons of water over the span of an hour. We're going to measure the starting temperature, the end temperature, and from that we should be able to calculate how many BTUs we put into that, and then the equivalent of how much electricity that would have taken. So then we should ultimately figure out how much money we saved ourselves. So this rocket stove has already had one modification already. I lit it up for its very first test a little while ago, and it had some issues that I had to address. I plan on taking you a very quick build process of this. There's going to be a build video coming out after the fact, so if you love build videos, stay tuned. You're going to want to see that. Today, it's all about performance and testing. So, as you see, we already lit the stove up. So once it gets up to a nice temperature, we're going to monitor the water starting temperature, and we're going to time it for 1 hour. Let's burn this thing as hot as we can, and let's see what temperature we can rise that water to, and then let's run some numbers at the end. So this is going to be the body of the rocket stove. There'll be an ashtray and everything in here, and a little bit of a grating to hold the coals up. This would be an air inlet. There'll be a damper. The wood would feed in here with a lid, and then normally this would be taller and you'd put a grill on it or something, but this is where the water jacket is now going to sit on top of here. So that's going to be the next part I start making. I have to leave that part separate until I get the tubes in and everything like that, and actually create the watertight jacket. But we can start assembling some parts and getting a better idea of what it's going to look like. Fits pretty good. I've got it kind of tweaked a little bit right now to get the front tacked in, and then I'll straighten up this back so it's not so ugly, and get some tacks in on all these little tabs here as well. really nice. The only problem I had were in some of these corners, there's a little bit of gaps and I had problem filling them in. But other than that, I'm really happy. We got all these tubes. Most of the tubes were all done with just a fusion weld. I had to add very, very little filler. Well, I am really happy with how this is turning out. I went ahead and I put a nice little handle on the door and we got the damper in place. You can see all the boiler tubes, our inlet and our outlet. Yeah. I'm lucky enough to have a few helpers here today. They're going to be keeping this rocket stove fed, and maybe I'll even convince them to hop in that tank afterwards. You might see some water coming out around the water jacket, and I was fooled on my first test. I thought I had a leak, but I've pressure tested this vessel and it doesn't leak any air. So all that water coming out right now is purely condensation from the combustion and those gases condensing on the cold water jacket. And I think once we start bringing the water up in temp a little bit, that little bit of condensation dripping out should slow down. Now, if you're new to rocket stoves, the way they work is by relying on a really aggressive burning fire. So you have to have your firewood in fairly small pieces, and our draft down at the bottom is probably going to stay wide open. We want this wood to burn as fast and as hot as possible. That is the whole goal behind a rocket stove. So we're going to try and continually keep this thing stoked up real good.
That's scary.
And yeah, once I feel like the stove's up to temperature, I'm going to write down the starting temp of the water tank. So we'll take a quick look at our setup here. We have the rocket stove over there, which I just stoked up. I got a bunch of garden hose, because that's just what I have available right now. And I'm circulating the water with a hydronic heating system pump. So I have an outdoor thermometer that I sealed in a vacuum packed bag. It was just the easiest way to do it. We submerge that in the tank. Right now, we're sitting at about 7 degrees water temperature. And once I'm convinced that the rocket stove is up to a fairly normal operating temperature, let's write down the starting temp. We're gonna set the clock for an hour and let's see what we can do. I have some pretty high hopes for this. I've been playing around with different forms of water heaters in the past, and I must say, being able to heat water on demand where and when you need it sounds like a trivial thing, but it can actually be really handy. Hey bud.
Hi.
I had my water line freeze. Okay. I had my water line freeze this winter because we draw off the lake we live on, and it was frozen for about a day and a half until I could get my water heater rigged up, and I was able to pump water with a temporary pump out of the lake up through the water heater one pass, and it came out scalding, so that I was able to put it down the sleeve pipe our water line's in, circulate it for about 30 minutes, and that completely thawed out our water line. And I even had a heat trace in there too, but at 3 watts a foot it just wasn't enough to keep that line from freezing. So it turned out to be extremely beneficial that I had a method of pumping and generating hot water independent of our house. Okay, well, we have my son and my niece here. Now, Harper, can you feel the water? And now feel the water coming out of the heater. It's not hot, but it's significantly warmer, isn't it?
Wait. Oh, it's cold. Oh, it's warm.
Yeah.
I want to drink it. Can I drink some?
I don't care if you drink it.
Oh, can you bring it to my mouth then? I'm crazy.
Okay, let's check on this stove. Oh yeah. Oh yeah, okay. It's gonna require a lot of feeding.
Oh, we're getting it off. These ones are wet.
Okay, well, I have more up on the shelf over there.
Wasn't there? Okay, so I will get one.
Okay, I think we're pretty much there. The stove seems to be really hot. It's burning a lot nicer, and I can tell because last time, you'll see, when I was trying to start this up for the first time, I could not get that flue hot enough because it just was not drafting well enough. And it seems to be working pretty good now, so we're gonna record that starting temperature and set the clock for 1 hour. All right, let's start the clock. Started at 12, we're gonna run it till 1, and we're starting at 8 degrees Celsius. I'll throw the Fahrenheit equivalent up on the screen here. So now we're just gonna play a waiting game, and let's see what this can do. I'm pretty excited. I think the BTUs that this will put out will probably surprise you. I know they're probably gonna surprise me, but let's see how it goes. I don't know if you're going to be able to hear this. I'll flip the mic around. Okay. Okay, just 1 sec. All right, I think you'll be able to hear that. It is drafting and getting into its rocketing mode. A lot less smoke coming off of it, but still, I can almost put my hand over top of it here. So the smoking has mostly stopped, and I can have my hand over that. So you have that rocketing fire down there going through the water jacket, and it's coming up such that I can put my hand over it. Now, if you're familiar with rocket stoves, you will understand you never would want to have your hand over a rocket stove. But what that's telling me is that a lot of that heat energy in there is going into the water, because there's very little coming out up here. I don't know about you, but I think that is really promising, because I've seen these rocket stoves. Unfortunately, I don't have an IR thermometer right now. I can't seem to find the one I have. But I've heard these rocket stoves, you know, they get up to about 1,000 degrees Fahrenheit. And the fact that you have something in the neighborhood of 800 to 1,000 degrees right down here, and I can put my hand up above this, that only means one thing, and it means a lot of that heat is going into the water. So that's really cool. I didn't think I was going to be able to do that. I was actually expecting to put a grill on top of this and still be able to cook something on it. But what this is starting to tell me is there's no point to do that. Now, because this water jacket just sleeves over the stove, I do have a plan. I can just make up a straight flue, no water jacket, and then use that for a cooking stove. But we are taking a lot of that heat out of the fire, which is really good for efficiency. That's what we want. All right, well, we're right here at the 1 hour mark now, and I'm pretty impressed. We have managed to accomplish approximately 18 degrees Celsius. Again, I'll throw the Fahrenheit equivalent up on the screen there, in 1 hour. So we started with 100 gallons of water at approximately 8 degrees Celsius, and in 1 hour we were able to raise that temperature to 18 degrees Celsius. So with that, I'm going to go ahead and calculate how much heat energy in BTUs we put into the water. And I'm going to represent that as BTU hours, which is a direct equivalent with a conversion factor to kilowatt hours. And then we'll go ahead and try and estimate how much energy we put in and what that would have cost you in electricity. I'm going to wait for that. I'm going to crunch the numbers, and we'll close out the video with some of the facts and information about this rocket stove water heater. So the stove itself, I'm pretty impressed with. You can definitely feel an inlet and an outlet temperature. It's not, crazy drastic. When the stove is burning really nicely, there is very little smoke coming out the flue. Surprisingly enough, I can still hold my hand over that for a little bit of a period of time, And as I mentioned earlier, if you're familiar with rocket stoves, they're usually shooting flames out the top. So we are doing a quite effective job at capturing a lot of that fire heat energy into the water that's going into the tub. And I found if I overstuff this, it doesn't draft the greatest, but right like this, it's perfect. A nice, steady, really hot fire, and it's going all up the flue. So in comparison to this, to the other water heater that I made for our hot tub, I have gone through maybe 3 small birch logs, approximately 10 to 12 inches long. I cut it up into small pieces. It's really not much wood. And by comparison, in my other heater, to take that stock tank full of water, about 300 gallons, and heat it up to a hot tub temperature is well over 3 wheelbarrow loads of wood. So even though we're doing a smaller test than a full hot tub, I think we've already seen that the efficiency out of this is significantly better than my other one. However, the other one will probably heat it faster. If you have the time and efficiency is your goal, this thing is working really well. Let's go check out that other one. So here's the other one here. Remnants of a hot tub we had this winter. It's a bit crude and archaic. It's seen quite a bit of use. I slapped it together pretty quickly because, I mean, when you're just playing around, there's no point a ton of use, but the design on this heater was having dual flues, and I can slide this shutter back and forth. So if the hot tub gets to temperature, so if we have a rip-roaring fire down in here, I can pull that lever over, the slide goes over, blocks off this flue, and redirects a lot of the heat out of here so that all this copper tubing I had in here doesn't get overly hot, and it stops heating the tub. And as you can see here, it was basically the same idea. Cold water in the bottom, hot water out the top, and I used a forced circulation. And I forget how many tubes I had in there, but they're spaced apart quite a bit. And it took a very, very large fire down in here to really get this water hot. You know, with the rocket stove setup, you're really going for efficiency. It's a very high draft, aggressive burn, and I'm trying to capture as much of that heat out of a small amount of wood as I can. And being able to put my hand over the flue is a really good example that I think I'm getting some pretty good efficiency on the heat transfer. Let's finish getting some more wood in this. Now I found filling it too much was a bit of a problem because it really stopped that draft. So I'm not going to try and put too much in here. We'll let that keep going. Oh yeah, it's warming up nicely. Since it's such a nice day out, the kids are having a ton of fun. I'm going to keep going with this test, and I want to see how long it's going to take to get this up to a nice hot tub temperature. You know, 104 degrees Fahrenheit. I forget what the Celsius equivalent is. My apologies, we're up here in Canada, and we're a very odd mix of both metric and standard. Sometimes use them interchangeably, and sometimes only stick with one. Can't explain it, we're just weird mutts up here. But we're currently at about 20 degrees Celsius, a little over 1 hour in. And you can definitely feel the temperature difference between the tub water and the water coming out of that hose. So yeah, I'm just gonna enjoy myself, keep feeding this fire, and let's see where it goes. So my father-in-law warned me, having the sleeve on the outside, I was going to get a lot of creosote buildup. And that is going to be the case, definitely. but I think it's actually helping me because a lot of the condensation from the flue gases hitting the cold water jacket up here are actually draining down the outside and boiling off versus falling down into the fire. So even though it's going to make a mess on the outside, I think it's actually helping me. And this fire here is drafting very well now. You can see it's sucking the flames back and up the flue. All right, Carter here's got a ton of birch bark. He wants to throw this thing into turbo mode. Okay, throw it in.
Oh, shoot. No, go. And, okay, now you can try to. That was awesome.
So the stove's been burning for about an hour and a half now, and some interesting things to note is the water has heated up enough so that it's not condensating and dripping out outside the stove anymore. And you can really hear the drafting on this thing now. It's burning up the firebox, but it is sucking all those flames right up through the flue and through the water jacket. All right, we are 2 hours into this now, and I want to do this for a few reasons. I think it's working well enough that I may actually get a hot tub out of this today. Second reason is I wanted to see if that first hour on the heat up would be repeatable on the second hour, and I think we're actually getting more heat on the second hour now that the stove is completely up to temperature. It's burning good. The condensation has completely stopped, and it's so hot the creosote even all burnt off. So we have a really nice draft going. I just filled this up quite a bit, but it's even drafting up the fire or the wood chamber here. It's drafting those flames down. When I have this lid down, it pulls them down and all the way up. So that's really good. I'm really happy with that. The draft doesn't seem to be a problem. And at the 2 hour mark, we are 27.2 degrees Celsius. I'll throw the Fahrenheit equivalent up on the screen. The water itself is doing really good. 27-degree water, that feels really nice. And the water coming out of here now is, oh, that's really warm. That right there, that water coming out is easily hot tub temperature. It might even be too hot for a hot tub. Now, it needs to mix in and cool itself off a lot still. I think I'm gonna keep this running, and I wanna run the numbers, and I think at the end, like I say, we'll throw all that information on the screen. I wanna look at the BTU and the kilowatt calculations for the first hour, over 2 hours, and then over 3 hours. And let's see if those seem very similar per hour. I think we're going to actually see that the second and third hour we're able to put more BTUs into that water because the system had pretty much come up to temperature. We got the draft and the burn on this rocket stove working really well. It took a little longer than I thought. I am no rocket stove expert, but I'm really happy. This is pretty cool. I have used very little firewood. You know, a standard 16, 18 inch piece of firewood, I've maybe gone through 3 or 4 of them. You got to cut them down into really small pieces so they burn really aggressively and fast, and that way you get all that heat and good energy out of them. And it's largely quite contained. So cool. Let's run this for another hour and see where it goes. I don't know if you can see it, but we got steam. Oh yeah. It's about +3, +4 degrees Celsius out here today. So in all these calculations, something I want to mention is I'm really probably calculating on the low end because I'm going to neglect all of the heat loss from, you know, all the long garden hoses I have and this big open tub of water. If I was to get a more accurate measurement of the BTU this is putting out, I would want to have my tank of water closed and maybe even insulated, and I bet you'd see probably a 20 to 50% increase in BTUs calculated, but this is a pretty big tub. I'm not going to bother with that. I'm really more interested in the real world numbers on how long it's going to take to heat up our hot tub, because we use this thing quite a bit. It is super handy. I'm really loving how this is working. All right, here we are, 3 hours in, and we are officially at 34.1 degrees Celsius. Again, throw the Fahrenheit up there, and that's pretty warm. I mean, the outlet temperature of the hose is next to scalding, so I would assume within another hour this is probably hot tub ready. It's not quite a full tub here. The kids are sure having fun with it. But something to know about the stove is I have been tending it fairly regularly, but it's actually building up too much coals, which has, let me see here, which has stopped it from drafting as good as it can. I am not a rocket stove expert, so if anyone is, give me some tips here. But I was kind of finding that all the coals building up were really stopping the draft from the lower damper here. And in order to get the best draft, which seemed to be the most smoke-free fire, I needed to leave my fuel door open, which I don't think is the idea. I think you really want that draft coming up from the lower part of the K and up and burning that wood, and you just keep feeding it in. Whereas my fire has migrated up into the fuel hopper, and it is pulling those flames down and up the stack, so I think it's still working. I don't think it's ideal though. So one idea I have is to make my openings in my burn grate a little bit larger so more of those coals can drop down into the ash pan, which should let the oxygen come up and feed the fire better. So I think we could improve upon this and get a little bit better burn, which means a little bit more BTUs, more energy into that water. As you can see here, it's coming right out. So yeah, I think it's been working really good. We're going to go ahead, crunch some of those numbers, get them up on the screen, and talk about it a little bit. There are definitely a few more changes to make, but there are a few aspects I'm really liking, and we'll see. See if I feel like tending this for another half an hour. We might have to have a quick little hot tub, or maybe even let the kids jump in it. What do you think? Yeah, I'm getting a bunch of nods. Okay. Well, we'll see how this goes, and I would love to hear if you know anything more about rocket stoves. Drop me some comments on things that I could change or improve upon, because this is all fairly new to me, but it seems to be working quite well, so I think it's worth putting a little bit more time and energy in. Alrighty. Well, we were having so much fun outside, nieces and nephew over with my son, and sun was shining. It's just such a fun day. We went ahead and I have run this for 4 hours now. And I definitely learned a few things. So in 4 hours, we have this tub. I don't know if you can see the steam in the background or not. We have it at almost 37 degrees, which, that's only about body temp, but it feels warmer than that. So it's near hot tub temperature. And I think the kids are actually going to jump in here and have some fun. So that's pretty cool. This was all done by a rocket stove this is all done by that rocket stove with a very little bit of wood. I did tend it all day, but I learned a few things. So I am fairly new to rocket stoves. I've loved the idea for a long time, kind of built one years ago, but I decided it's fun doing redneck hot tubs too. So I want to build a rocket stove that can also heat some water. So after studying some of the designs out there that work really well, I came up with this one. Now, one of the biggest issues I've been having after running it for a long period of time is the coals have been burning up in, the burn chamber, so much that the lower part of the K, I guess this is referred to as a K-style rocket stove. the coals built up so much that it wasn't flowing through the bottom up and out through the top. It has really been relying on having this fuel door open, and I've tried closing it a bit before, but it really seemed to rock it the best. You know, when that combustion's happening really fast, it's aggressive, it's hot, it seemed to happen the best when I had this K-door open a little bit, say after about hour 1. Hour 1 was pretty good. You'd have the door closed and you could hear this thing going, and it was putting a lot of heat in. After that, the coals started building up and it really closed off that burn grate I had, and it's been relying on this fuel door open to really get the draft going. I don't know if it shows up the same, but it's really sucking through. But there's so much coals in the bottom, probably see them up through there, that this lower assembly, there's no air going through that. You'd play with this, it doesn't change anything. Nothing. So there should have been air going up through there. All that really means is that this thing should have been burning hotter for longer. However, because of that airflow, it's not ideal. Because of that rocket stove was building up so much coals, it was really compromising the draft. The first hour ran really well. The second hour wasn't too bad, but hours 3 and 4, I had to leave that fuel door open and allow a draft through that way, and that wasn't really the design of that K-style rocket stove. So I think I have a few ideas. I'm going to open up some holes in that burn grate to let some of the larger coals through, which should allow that fire to burn through the normal draft hotter longer, which I think would improve our our BTUs, or our warming of the water, quite a bit. I'm really happy with it. I mean, we heated 100 gallons of water just about 30 degrees in 4 hours. So come summertime, this thing's not going to have any issue heating up our hot tubs for us. And it's pretty cool. Like, the thing, when it's rocketing, you can tell. And I think I've had some sound clips there that you could really hear the rocket happening. I think that's going to be all for tonight. I'm going to run all the numbers on everything, and we'll get back and finish up this video. But I think there's definitely going to be a few more modifications and some more tests done. We're not done with this yet. It's pretty cool. I'm starting to get an idea of adding in a waste oil burner into this too. Yeah. All right. Well, I'm going to have a fun night, let the kids have a hot tub, and we'll run some numbers and finish out this video tomorrow. All right, there we go. This thing is running. The water jacket is empty, and it is hot. Look at that. That is hot. There's no doubt about it. The fire's burning wonderfully. Alrighty, well, it's many days later. Finally got around to finishing this video up. The kids had an absolute ball. They had so much fun, and that's really what this was all about. I got to play around, make something I've wanted to do for a while. Well, I'm going to keep playing around because it's not done yet, but put the two together and we just had a great time. So a little bit of numbers on this thing. If I didn't mention it earlier, it's all stainless steel, so really it can run dry as well. The water jacket, when you subtract the amount of area that the tubes all took up, is approximately 2.5 gallons of water is what it holds. And yeah, it's all stainless except for the aluminum support on the bottom. In order to calculate those BTUs, it's a fairly simple calculation. We take the weight of the water that we heated up and the change in temperature from start to finish, and then there's a coefficient, but for the purposes of this calculation, the coefficient's 1. So it's really just the weight of the water times the change in temperature will give us the BTUs we put in. And since we did 100 gallons of water, I believe the weight is about 8.34 pounds per gallon. So we heated approximately 834 pounds of water. And the data should be up on the screen here. In the first hour, we put about 15,000 BTUs into it, which is the equivalent of about 4.4 kilowatts of electricity. The second hour, it actually went down, 13,677 BTUs, and the third hour was 10,341. Now, I was kind of expecting the opposite, but I believe I know why that happened. It was largely due to the buildup of those coals. The draft slowed down, unfortunately, and I just couldn't keep the heat going in the way I wanted it to. So by making some modifications down in the burn chamber here, opening up that burn grate, and we'll see what other things we can do. I hope to bring some of those numbers up. I'm also wondering about putting on another kind of square piece of stainless that will bring some of those flue gases up and around and out the outside and then back in, which will help to put a little bit more heat into the water, but it'll also increase the draft. I'm a bit concerned that we have this choked off. When I calculated how many tubes I put in, I calculated the inside area, cross-sectional area of them, and I wanted that to match approximately a 4-inch by 4-inch stove. This is a 5 by 5. So I do know that I did put quite a bit of tubes in to not reduce the draft, but it might need a little more. That wound up being, over the course of heating the tub, we put in approximately 39,000 BTUs, which I think equates to about 11.4 kilowatts. That's actually not a ton. I was kind of expecting numbers to be a bit higher. And in terms of the equivalent in electricity cost, you're talking about $2.50. So probably would have been a lot faster and cheaper just to heat with electricity. But the whole idea behind this is it's small, it's portable, we can take it camping, you can use it off grid. I did use a 120 volt hydronic heating system circulating pump, but you can easily use like a 12 volt circulating pump. I actually bought one for this test, but it was a little loud, and since I have 120 volt power, quite accessible here at my house, I opted for that. But this can easily be made into something off-grid or remote use. And if you're just wanting to heat a small amount of water for a shower or something like that, or a smaller tub, I think it has a lot of potential. I have some ideas about maybe upsizing this to, say, a 7 or an 8-inch stove and really put in some bigger wood. I don't know if the theory behind a rocket stove will scale up, but I'd be curious to see if that works. So with that being said, I hope you really enjoyed this video. I had a ton of fun building this. I've never done so much stainless welding before, so that was kind of a new experience. It went really well. I learned some new techniques, I learned some things about rocket stoves, and the kids had a ton of fun, which is the most important. So with that being said, thanks for watching this video, and as I mentioned earlier, there is going to be a separate full detailed build video coming out on this, so if you're into that kind of thing, check it out. Also go check out, we're working on a massive custom built aluminum snowcap project, and I really just do whatever my brain feels like doing, so there's always some unique random projects poking up. Thanks again, we'll see you in the next one.